Physicists warn Earth could feasibly descend into chaos. The impact of human activity on the Earth system could result in unpredictable chaos from which there is no return, physicists have calculated. Using a theory conceived to model superconductivity, a team of physicists led by Alex Bernardini of University of Porto in Portugal showed in a preprint paper this year that after a certain point we will not be able to restore equilibrium to Earth's climate. A finite amount of human activity could result in a hothouse Earth from which there is no return, the research suggests. They detailed their work in a paper made available April 2022 on the preprint server ARXIV, which remains to be peer-reviewed. The implications of climate change are well known: droughts, heat waves, extreme phenomena, etc. Physicist Orfeo Bartolami told Life Science last year, "If the Earth system gets into the region of chaotic behavior, we will lose all hope of somehow fixing the problem." For some years now, extreme weather events seem to be occurring more regularly. Wildfires blaze, storms rage, temperatures reach new records. Climate scientists have warned that this is a consequence of human activity. Well, we know that in Europe, most wildfires are arson. So human activities such as burning of fossil fuels, deforestation, and increases in farming. This has led to the proposal of a new geological epoch, the Anthropocene, a period in which human activity has led to a significant and marked impact on the entire Earth system, comprised of the geosphere, biosphere, hydrosphere, and atmosphere. The Anthropocene would follow the Holocene, which started around 11,700 years ago, and scientists propose its beginning around the middle of the 20th century, the peak of the nuclear era. Bernardini and his colleagues decided to model the transition from Holocene to Anthropocene as a phased transition and calculate its future trajectory accordingly. Phased transitions are very common. The term refers to how a material changes from one state to another. A solid melts into liquid, the liquid boils into a gas. A metal transition from normal state to superconducting one. Each of these has a tipping point at which an equilibrium stage undergoes a profound shift into another state. The Earth system is not a material, but rather shows that phase transition modeling can be used to predict climate shifts with some success. Bernardini and his colleagues used the Ginzburg-Landau theory developed to model superconductivity and applied it to the Anthropocene based on temperature starting at Holocene equilibrium point. Now, human influence is limited. Our world has a finite amount of habitable space, a finite amount of resources, and a finite rate at which we can use them. Given this maximum capacity, the researchers decided to map the possible outcomes of the Anthropocene phase transition using a logistic map, a tool to explore how complex outcomes and even chaos can evolve from a simple point. Their results showed that we are not necessarily heading for certain climate doom. We might follow quite a regular and predictable trajectory, the end point of which is a climate stabilization at a higher average temperature point than we are at now. That's still not great, given the deadly effects we're already seeing on humans and other animals. But at the more extreme end, Earth runs into havoc. This means that the planet system evolves into chaotic behavior, extreme seasonal fluctuations, and weather events. That precludes prediction of the future behavior of the system, making it impossible to mitigate. And that means it would be extremely difficult, if not impossible, to claw our way back to a stable climate. Dividing the human activities into the multiple components, we have studied a case with only two of these components following logistic maps and interacting with each other, the researchers write. Even for this simple case, we observed the emergence of chaotic behavior in the equilibrium points of the Earth system, and this leads to potentially important consequences if at least some components of the human activities actually follow logistic maps, which is a quite reasonable hypothesis, given the physical limitations of the planet-wide system that we live in. This outcome is not inevitable, which is something of a relief, but the researchers say we need to consider a real possibility for designing strategies to mitigate climate change and manage the Earth system in the future. The paper appears on preprint Survey RxRV, and the article was published June 2023. It's on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.